Irodov problem number 1.241. A uniform disk of radius r has a round cut as shown in the figure. The mass of the remaining shaded portion of the disk equals m. Find the moment of inertia of such a disk relative to the axis passing through its center of inertia and perpendicular to the plane of the disk. So we have a uniform disk. Okay, and this is radius r, and then we have a disk of radius r by 2 which is cut out from here. So the only part of the disk that is there is this purple part is cut out. Okay, now so let me do the shaded part. Let's think of this as two disks. One is the full disk, another is the small disk. Okay, and then we can subtract the moment of inertia of the small disk from the big disk, so we can get the moment of inertia of the resultant body. Okay, so let's say IB is the moment of inertia of the big disk about its center of mass. So something like this. So IB is moment of inertia of this about its center of mass. So what would that be? Half mass of the big disk times r square. Okay. Now let us take the smaller disk, and moment of inertia of the smaller disk, let's say IS, about its center of mass. Now this distance was r, however this radius is r by 2. Okay, so IS we can write as half mass of smaller disk times r by 2 square. Okay, or we can also write this as 1 by 8 ms r square. Okay, now don't make the mistake of subtracting IS from IB to get to this. That's not the question. The question is moment of inertia of this body about a point which is the new center of mass. So if you cut out a piece from this, the center of mass will shift. Now it will shift on this line. It will definitely be on this line. Why? Because it is still symmetric. However, this will be shifted here because we have more mass here. Now, how can we find out this distance, let's say? It's very simple. We can use the formula x center of mass, which is, let's say, this based from this origin point. How far is the center of mass? So this distance is xc. Mass of first body, so first body, let's say, is the big body, big M, so the entire disk, times its distance from the center of mass. Now let me just write it down, x1 plus mass of second body, which is the small body, times x2 divided by mb plus ms. This is the generic formula to find out the center of mass. Now in our case, mass of big body is whatever, but x1, which is the distance from the reference point of the center of mass. So x1 is actually 0. Now mass of the second body, which is the small this thing, this is negative. So I can write minus ms, because we have cut that out, times the distance of the center of mass from O. Now distance of the center of mass is minus r by 2. So we can write minus r by 2 divided by mb minus ms. Okay. So we can further write this as ms r by 2, so 2 mb minus ms. Or if I divide numerator and denominator by ms, we can write this as r by 2 mb by ms minus 1. Now what's the relation between mass of the bigger disk and the mass of the smaller disk? So mass of bigger disk is density times volume, which is pi r square times 1, which is, let's just think of it as unit thickness. And mass of smaller disk is rho times pi r by 2 square. So mb by ms will be pi rho r square gets cancelled. So 1 by 4, which is 4. So from here we can write r divided by 2 times mb by ms is 4, 4 minus 1 is 3, 3 times 2 is 6. So this is r by 6. So this distance xc came out to be r by 6. Okay. Now, how do we use that? Now see, moment of inertia of the big disk about its center is this. But that's not what I'm interested in. I am interested in moment of inertia of the big disk about the center of mass, about this, the new center of mass, which is at a distance xc from the original center of mass. So we can write, using the parallel axis theorem, IB dashed is IB plus mr square. So MB times the distance xc square. So this becomes half MB r square plus MB. XC is now r by 6, so r by 6 square. We can write this as half MB r square. Let's take that common. 1 plus 36. But I've taken 2 outside, so 1 by 18. So 19 by 36 MB r square. Okay. Okay, now let's look at this. Moment of inertia of the smaller disk about not this axis but about this axis, which is at a distance of r by 2 plus xc. Okay, so we can write this is dashed as is mass times the distance between the axis and the new axis. Okay, so that is r by 2 plus xc square. So is is 1 by 8 ms r square. This is r by 2 plus r by 6. So we can write 6, 3, 4, this square, so 2 by 3. So 1 by 8 ms r square plus ms 4 by 9 r square. So 72, 9 plus 32 is 41 ms r square. Okay. So now we have the moment of inertia of the bigger disk about this and moment of inertia of the smaller disk about the same axis. Now we can do resultant I of this disk as IB dashed minus IS dashed. So as if I computed the moment of inertia of the bigger one through this minus computed the moment of inertia of the smaller one through the same axis. Okay, one other small thing that we need to do is it's given MB minus MS is M. So MB is 4 ms, so 4 minus 1, so 3 ms equals M, or ms equals M by 3, and MB equals 4M by 3. Okay. So we can further simplify this. As 19 by 36, MB is 4M by 3 r square. So this is 4 9s are 36. So 19 by 27 mr square. And this one we can write 41 by 72. ms is M by 3. M by 3 r square. This is 41 by 216 mr square. Okay. So IB dashed is, so mr square we can write 19 by 27 minus 41 by 216. Eight into 19. 152 minus 41, which is, so 111 by 216 mr square, and divide by 3, then 9, 3 7 is 21, 3 7 is 21. So this is, so let me write this here, I is equal to 37 by 72 mr square. So that's my answer.